Our test on the conic sections is coming up on Thursday. So I just wanted to go through and review each of the 4 shapes and what kinds of things I'm expecting to be able to show me on the test. Okay, so we started out last semester talking about circles. What was the basic equation for a circle with a transformed center, right? If we shift it, x minus h, quantity squared, okay. So what are the key things for a circle that I would expect to see on a graph? Okay, I need the center. How do I find the center from my equation? Okay, and what else? The radius. Okay, so you should be able to give me the coordinates for the center. You should be able to tell me what the radius is and draw the picture. Yes? Okay, next shape. For ellipses, what was our transformation equation? Okay, we'll say over a squared first. Okay, now we have a second version of that. So somebody else, what would the second version do? What changes? Okay, so these two can flip-flop. So how are we going to know if we're looking at an equation and there's numbers there? It doesn't say this is A, this is B. How do we know which one is A? Okay. So A is always bigger than B. So what are the key things if I were going to have you graph an ellipse? What were the things you would need to know? Vertices. Somebody else? Okay. I need a center, right? Got to start with a center. Covertices. Okay, need those. Think about an ellipse. Did we have asymptotes for an ellipse? No. Okay, so for an ellipse, we need center. That's our starting point. And then we're going to measure out A spaces to get our vertices, right? We're going to measure out B spaces to get our covertices. And those we're getting right from the equation. But how do we find our foci? We have to know C. How do we find C if we know A and B? C squared equals, good, A squared minus B squared. So that's the information I would need you to be able to figure out about an ellipse. Yes? Okay. Our next shape was hyperbola. Okay, somebody else. Basic transformation equation for hyperbola. Give me the whole thing though, transformed. Okay, I need somebody else to help out here today. We don't have just one student in the class. Somebody else, help me out. X minus h squared over. Okay. All right. So what flip-flops in a hyperbola? Okay, instead of a plus for an ellipse, we have a minus for a hyperbola. But in this equation, this is one version of it. We have a second version. What changes? The tops, okay? So sometimes the y piece will be first and the x piece will be second. Yes? So when we're looking at an equation that just has numbers in it, how do we know which one's the A? It's always first. Okay, so in a hyperbola, your A piece is always going to be the first one. All right? So what are the things we would be able to pull out from this equation to do our graph? Starting with center. Okay, which is our HK again. Somebody else, what's another thing we can get? We can find vertices. How do we find the vertices? We measure from center out to the vertex using what measurement? A. Yep. And then what else? We do want to find foci. To find foci, we would need our C value, right? Just like an ellipse. What's the formula that gets us C if we know A and B? C squared equals, okay. Now, do we label B? We draw it on our graph, but we don't call it anything, right? We don't give it a name because our graph doesn't actually touch it. B is there just to help us do what? Make that box. So I would expect to see the box drawn, right? Using your A's and B's. What else do we draw in? Asymptotes. I would expect an equation for the asymptotes. Yes? So we have our y piece equals plus and minus, because one asymptote has a positive slope and one has a negative. And then whatever the slope is times our x piece, right? Okay. And then our last shape, parabolas. What's our basic equation for parabolas? What? X squared equals 4py. Okay, let's transform it. If we shift it, x minus h squared. Okay, or we could have the other one, right? The y piece could be squared. Okay, so what are some things that we would need to know from this in order to graph it? Vertex this time is found where? That's the HK. So in all of the other shapes, that was this called the center, right? We call it the vertex here. Vertex is HK. What else do we pull out of our equation? In order to find the focus, we have to figure out P, all right? All right, so P is going to be that directed distance from your vertex to your focus. Okay. What else? So we've got our vertex. We're going to be able to find our focus. What else do we usually put on there? What is it? Directrix. Okay, now remember directrix is a line, right? So you're going to give me an equation for a line, x equals something, y equals something, all right? And then how do we know how wide to make it? We need that focal chord, right? So we take the absolute value of 4p. So we don't worry about it whether it's positive or negative, but we take that 4p piece, all right, and we split it in half, right? We'll say half on each side of the focus. Okay, that gets you your other 2 points, so you can tell how wide to make that parabola. Yes? Questions? All right, so for your review, you're going to get a half sheet that is due when we take your test on Thursday. I'm also, though, going to give you a short Chapter 8 review for the final, okay? Because remember, we have a final coming up next Friday. So I want you to start over this next week and a half here. We're going to be starting to feed in a little bit of final review stuff along the way, okay? So the blue review packet for the final, I would strongly encourage you to do those questions before Thursday's test because it's all on Chapter 8 conics, but I'm not going to collect it until we are ready for our final. Does that make sense? Okay.